Hi, I'm an old guy and I do maths, and today we're looking at permutations, call them arrangements if you will. You usually strike this somewhere early on in probability, um, and what we're going to investigate is the number of ways in which we can arrange the letters in this word, and notice that I've carefully picked a word where there's no repetition of letters, because that's another story. So our first set of choices is from a group of 5 letters. Now we're assuming that you don't replace, so this is without replacement or repetition. So the first choice is 5, so we have a choice of 5. Next choice comes down to 4, 3, 2, and 1. And if you want to think of another way of looking at this, imagine an example that you will have seen very early in probability. 2 dice, you throw them. The possible combinations are 36. There are 36 ways in which those letters those numbers can be combined. And order is important. For permutations, order is important. So there's a difference between, let's just say, if we take these 2 letters, there's a difference between IN and NI. That's by way of example. Anyway, the way in which you work out the possible number of permutations or arrangements of the letters in this word is as follows. 5 times 4 times 3 times 2 times 1. Now, those of you who've looked at factorials before will recognize that this is, in fact, this 5 factorial. And 5 factorial gives us 120. 5 fours are 20. 20 times 3 is 60. Times 2 is 120. So, there are 120 ways in which the letters in this word can be arranged, order being important. I'll keep coming back to that. Order is important with permutations. Okay, so what's up next? Right, well, here we've got the same word, but what we're going to do is we're going to limit our choices. So we're only able to choose 3 letters. Okay? So what happens then is we start off with 5, we go down to 4, and we go down to 3. And by the time we get to here, we've chosen 3 letters. And we've arranged them. And so there's a limit on the size of the set of letters that we can get. They all have to be 3 letters long, as opposed to the previous 5 letters long. And this is expressed mathematically as 5 times 4 times 3. 5 fours are 20. 20 times 3 is 60. And as if I haven't said it enough, order is important. These arrangements in 4 letters are all considered different for the purposes of a permutation. There are circumstances in which they're not considered different, but that is not a permutation. That is something else, and we'll come to that in another video. Right, so where do we move from here? Well, I think the idea is to get this into some sort of formalized notation. Now, the big P stands for permutation. And N is the number of, or the range from which we have to choose. So if we take the word train, we're choosing from 5 letters, so N is equal to 5. And if we decide, as on the previous page that we're only going to choose 3 of those letters. This is the notation for the limit of our choice. Now this could be 5. It could be 5 here and 5 here. But in the previous example, I used 5 and 3, so we'll make r equal 3. Okay, so here's the notation, but what does it mean? Well, it means the following. So it is your range of choices, the range from which you may choose, n, so your possible range of choices, n, over, that's factorial, n factorial, so in this case it's 5 times 4 times 3 times 2 times 1, as you'll see in a minute. And that is divided by n, again this total, minus the size of the choice that you must actually make. And this is often referred to as, so for instance, if it were 5 and 3, it would be 5 choose 3. You might put it that way. Okay. So n minus r gives us 2. So when we set this up, it is, in fact, n is 5, so that's 5 factorial, over, 5 minus r is 3, not writing very well today, 3 factorial, which is 5 factorial over 2 factorial. Okay, so we've got to that point. Now, let's have a look at how this all works itself out. So we would say 5 choose 3, and I've written this in this form here with n just as a reminder here that that's 5, and r just as a reminder that that's 3. And we're choosing 3 letters rather, from a selection of 5 letters, and order is important. So AIN is not the same as NIA. That's something that I'm sorry, I just keep hammering, but you'll see why when you advance a little further in this subject. Okay, so we set this up. We've got 5 factorial divided by 2 factorial, which leaves us 5 times 4 times 3, which I've got here set up. 5 fours are 20, as we saw on the previous page. 20 times 3 is 60. So there are 60 ways in which you can choose 3 letters from the word train and arrange them. Okay, and just to note here that n minus r in this case is equal to 2. Don't see that number there and put 3 down here. It is actually that number minus that number. Okay, there's an introduction to permutations. Later on in this playlist there are going to be some examples using this, but I hope that this made sense. Thanks very much for watching. See you next time.